So welcome back after a short break. After a short break, let's proceed to the next type of a lesson that we will be discussing as part of our review discussion. And this time, let's talk about the synthetic division. If you could still recall, before the Christmas break, our last upload or topic was all about the division. And And when we have this review discussion today, it is just like a continuation of the topics that we have, the process and what we were discussing last time. So there are different methods and process that you can use just to perform what is being asked in a given questions under the polynomial or algebraic expression. So after the remainder theorem, so the purpose again of the remainder theorem was only or is only to solve for or to determine the remainder without actually performing the division process. And this time, let's proceed to the type of division which is considered the synthetic division. And aside from this type of division or synthetic division method, there is also what we call the long method of division. And usually, this long method is introduced or was introduced to you when you were in lower grades. But this time, especially for grade 10 mathematics, not just for grade 10, but maybe for grade 8 and for grade 9. And for grade 10, one of the lessons is the synthetic division. And this type of division method is very useful in easier way to find the quotient and remainder. So as you can see, for the remainder theorem, this is the question, but this is the given question, and you only have to give the remainder or to determine the remainder. And even if you will be using synthetic division, you will still get the same remainder, which is negative 7 at the end, and we will find out that one later. So, how are we going to get the quotient in remainder using synthetic division? Simply, for this method, we will only be using the numerical coefficients or coefficients of each term of the given polynomial function. So, for synthetic division also, see to it that if the degree of the polynomial is 4, or if the highest exponent is 4, you have to consider also and remember that the lower exponents, just like 4, if the highest is 4, there should be the cubic or the exponent, which is 3 and 2 and 1 as the exponent before you will have the constant term. Because otherwise, you have to supply the missing term with these specific exponents. Okay, here. So, as I said earlier, you have to use the numerical coefficients only when using synthetic division for you to determine what is the quotient and remainder when this polynomial is divided by x plus 1. So, let's determine what are the numerical coefficients. So, for the first term, the numerical coefficient is automatically positive 1. And for the second term, you have negative 3. If it is minus, automatically it is negative. And the third term is negative 2. And for this fourth term, the numerical coefficient is positive 4 since it is plus. And you have here the last, which is the constant part, is negative 5, it is minus. And the same what we did for the remainder theorem, if for the given divisor which is x plus 1, you have to use the opposite of positive 1 or plus 1, which is equal to negative 1, and place negative 1 here as your synthetic divisor. And we call this one as this numerical coefficients and the constant, we call this integers as synthetic dividend. Let's continue. Just try to follow class because this is very easy. The easiest way for you to find the quotient and remainder when a polynomial is divided by another polynomial as binomial. Okay, the first step, after enumerating all or listing down the numerical coefficients and the constant, as well as your synthetic divisor, the first step to perform is just bring down 1. Okay, so bring down 1, and then after that, multiply 1 to negative 1. The result is negative 1, and you place negative 1 here under the second numerical coefficients. Then add negative 3 and negative 1. So when you get their sum, just bring down the common sign, and the answer is 4. And then you multiply the same process, go back to the first one, which is multiply negative 1 and negative 4 and negative 1. Again, multiply the sum, which is negative 4 to negative 1. So multiplying to the same signs, the result is positive. And 1 times 4, that is 4. And perform the addition again, just like what we did here. So 2 plus 4, since you are adding unlike signs, 2 unlike signs, so the result is you have to get their difference, and that is 2. And use the sign of 4, which is positive, so your sum is positive 2. Then, repeat the process, multiply positive 2 to negative 1. So, multiplying 2 unlike signs, that is negative, and 2 times 1 is 2. And add. So when you add this one, so still unlike sign, so the difference is 2. And since 4 has bigger absolute value and it is positive, so the sum is positive. Then multiply 2 and negative 1. So unlike signs, so you have to say that the answer is negative, and 1 times 2 is positive 2. And then add. So when you add 2 unlike 2 the same signs, bring down the common signs and add directly the numbers. So, for this synthetic division process, after performing the process here until this last digit, automatically the last digit, the last number integer of your sum is automatically your remainder of the given division. So just like for the remainder theorem, you will get the same remainder as long as you are following the correct and right process. And then your problem now is how to rewrite or how to write or express the result as the quotient. And for your quotient or q of x, simply just remember class. If the divisor is 1 degree or the degree is 1, and then your quotient is just equal to 4 minus, the degree of your quotient is just equal to 4 minus 1 here. Again, if the degree of your divisor is 1, which is the exponent is 1, then subtract this 1 from the degree of the given polynomial, the result is 3. And that 3 is the degree of your quotient. So for this one, just bring down 1 and then use variable x, and then just like I said, 4 minus 1, that is 3, so that is just equal to 3, which means that the degree of your quotient is 3. The highest exponent is 3. And proceed. If it is negative, automatic, that is minus, and then 4, bring down 4, weigh the variable, and then just supply the variable, and then with the exponent as descending order. So from 3, this is now 2 or squared. And then bring down 2. If it is plus or positive, automatic, that is plus. And with variable x, and from 2, descending order becomes 1, so automatic, that is 1 already. And then bring down 2. If it is plus or positive, that means plus. And the last part is always the remainder. So that means after the remainder, the number here is considered the constant term of the quotient. So you have now the quotient as the final, your q of x is equal to, just remove 1, that becomes x cubed minus 4x squared plus 2x and then plus 2, and your remainder, which is the r of x, is equal to -7. Okay, so that's it. That's how you perform, that's how the process is done with the use of synthetic division. So as simple as this, and I am wondering why this synthetic division method is not being included and introduced for the grade 7 students. Instead, what being introduced there for grade 7 is the long method of division, which is quite complicated, especially if the grade 7 students are very new and not very much exposed to algebraic expression. But anyway, the long method of division is still usable for the higher grades, for the higher level. It's just that synthetic division for me is quite easier to use when you determine the quotient and remainder when a polynomial is divided by another binomial polynomial. So that's it, class. So therefore, when p of x equals x raised to the power of 4 minus 3x cubed minus 2x squared plus 4x minus 5 is divided by x plus 1, the quotient, which is q of x, equals x cubed minus 4x squared plus 2x plus 2, while the remainder is equal to -7. So I hope this review lesson about the quotient and remainder with the use of synthetic division method is very useful to you and helpful for you to understand better when you have your review discussions, or when you need to have your review for the topic which is related to this one. And I am inviting you to be with me again next time for the next review discussions, but for this time, we will just up to this part. Thank you so much, and please do not forget to support my channel if this one will be uploaded. And have a great day.